Hey friends, this is Softwaring. Today I come back by another Ansys tutorial on spectrum analysis. So as you know, spectrum analysis is a way of analyzing the system when the base is excited. So this base excitation is applied on the system in the form of either displacement, velocity or acceleration. So in this particular video, I will show you how can you do this spectrum analysis of any system using an Ansysworkbench. So as you know the drill, the problem description is given to you. So if you see this description, we intend to it asks us to calculate to extract the first 10 natural frequency of this simple cantilevered beam. So this analysis, when you see the description, the beam model is built with 3 points at 500 mm distance apart from each other. If you take the density of the beam as a unit and set up the model with 2 mass points of 3 kg attached to the points. So as you see from the diagram, we can do this spectrum analysis by using Ansysworkbench. So to start with, since Ansysworkbench, spectrum analysis in the Ansysworkbench requires a model analysis as a prerequisite. So we have to start our analysis by clicking or double click on this model. Once this model is open, we have to check the engineering data. So in this analysis we do by using a structural steel material. So Ansysworkbench accepts this as a default material. So we can proceed to the project. So double clicking on the geometry, we have to plot our beam. So let us assign millimeter as our unit, and if you select one plane and make it normal, so we can start our sketching. So let us create a line. And let us dimension it. Five hundred millimeter. So from this sketch, by clicking concept, we can create lines from sketches. So then let us select the sketch, then apply. So we create a line from the sketch, and then if you generate it, we finish. Then after that, we have to add the cross section of this beam. It is a rectangular, so it is 10 millimeter. Yes, by default dimension is equal to our given dimension, so we create a cross section. So from one body is created here by expanding the tree, clicking on the line. We have to select our cross section. Our cross section is we created before. So if you generate, we finished our geometry stage. So let us close this. Then you can proceed to the modeling step. So if you double click on the model, it will open. Then by clicking the geometry, insert point mass. Let us hold point selection. Then at this point there is 2 kg mass, point mass, and then from the geometry insert again point at this edge, 2 kg again. After that, what you have to do is just accepting. Let's accept the default mesh. Let us generate the mesh. So this is our beam, discretized beam. Then we have to apply the fixed support at one end. So because this is a cantilevered beam, apply a fixed support. Then from the analysis setting, we can adjust our number of modes. So in this example, we ask to calculate the first 10 natural frequencies, then accept it. So if you solve this it will give us the first 10 natural frequency of this system. Once the solution is done, if you click on the solution state, you can see the first 10 natural frequency of this system. So once we did this, we have done this, we finished on our model analysis, so we have to proceed to spectrum analysis. To start with our spectrum analysis, response spectrum linked with this our solution, model solution, linked, drag and drop on the solution stage of the model analysis. So if you double click on the setup, so the Ansysworkbench will display like this. So from the spectrum analysis, we have to add the basic excitation. Before that, we have to fix, let us apply displacement, since the displacement arrest response spectrum displacement. So the boundary condition is all supports. The tabular data load will be here. So frequency 1, frequency 2, and frequency 3 has a displacement of 200, 300 and 400 millimeter respectively. So the direction is on the vertical direction, that's y direction. So we apply this. Before that, if you want to restrict the displacement in the z direction from the model analysis, let us apply displacement and let us select an edge selection, and if you select both, and then apply no displacement in the z direction. So if you solve this problem, it give us or the solution. Our natural frequencies will be we apply before, or are those the first 10 natural frequencies. So if you see the total deformation due to this basic excitation or this displacement load, let us add our total deformation from the solution stage of response spectrum. So if you see the directional deformation in the x and y direction, x and y direction, y axis, and let us say solve. So the total deformation will be, the directional deformation will be such a like, so the maximum will be 418 millimeters in the y direction. So this is how can you do a spectrum analysis of any system by using Ansysworkbench. So I hope this is helpful for you. So thanks for watching.